In this video, I will show you some strategies that you can use when facilitating Unit 7, Day 36, Lesson 18b, applying the quadratic formula, Part 2. What are common errors to avoid when applying the quadratic formula? How can we check if we made any of these errors? So within this lesson, the main focus is giving students opportunities to describe how they can check work using the quadratic formula or using other methods as well. So we're going to focus predominantly on the explore portion of this lesson, but I do want to point out that within this lesson, there are 2 opportunities for students to use the 3-read strategy to develop a deeper understanding of the scenario. So in the first part, they're given a scenario, they're asked to use 3 reads, and then they're answering a question around that scenario using quadratic formula and checking their work. And then the second situation, again, they're asked to use 3 reads and then go ahead and answer a question revolving around that scenario. It's really important to ensure that you're using the 3-read strategy, because by using 3 reads, it's going to give students an opportunity to really solidify a strong understanding of the problem itself, which will then make it much simpler when they come to the actual execution of solving the problem. And so for this lesson, I went ahead and put it onto a Desmos lesson. And you can see the first, so basically the first problem is the first 5 for slides 2 through 5. You have the 3 parts to the 3 reads, and then students are asked to answer this question. And then we have the second problem, the 3 parts to the 3 reads, and then they're given another question. And so for the summary discussion, for the facilitation of it for this video, I'm going to talk about how to facilitate a conversation predominantly around this second explore. So the questions reads, the equation h of t equals 80p minus p squared models the revenue a band expects to collect as a function of the price of one concert ticket. Ticket prices and revenues are in dollars. A band member says that a ticket price of either $15.50 or $74.50 would generate approximately $1,000 in revenue. Do you agree? Students have an opportunity to agree or disagree and explain or show their reasoning in these 2 spaces. So throughout the lesson, you can give students some time to work on this problem. You can also rearrange and focus your summary conversation on the other problem that comes before this. But the same idea is going to hold true for the conversation. When you come to the conversation and you're collecting student work, one strategy you can use is to collect work with students using various different strategies to verify that these are, in fact, verifying if these are possible ticket prices to generate $1,000 in revenue. And there are 3 strategies that I wanted to focus on that you might see. And I took snapshots of those strategies and I have them here featured. So let me just go through them quickly. So the first strategy I have is students actually using the quadratic formula to solve and identifying if those are the 2 answers, solutions to that quadratic formula. The second strategy is actually using substitution. And then the third strategy is using a graphing calculator. And so I ordered the strategies from most precise to least precise to help us facilitate a deeper conversation around this. You might order them from least sophisticated to most sophisticated. You might also choose to feature misconceptions if you see those popping up often. So you have to identify while students are working what works for you and what's going to generate a more clear understanding of the content at hand. And so the questions at the top of each of these slides with the snapshots is asking students, what strategy did that person use? What are the advantages and what are the disadvantages? And so for this first one, where we're talking about using the quadratic formula, students should be able to identify that. And then the advantages are that we're going to get a really precise answer. We're pretty precise right here. We did start to round and round when we found the square root of 2,400, but we do get a very exact answer. That's going to help us to really identify if the solutions mentioned in the problem are actually true. The disadvantages are that it's going to take a long time. It can be really tedious. It's easy to make a small mistake. And then the next one, what strategy did this person use? They use substitution. This is probably what you're going to see the most of. This is what students will gravitate towards, especially because it's a strategy that they've used in the past to check their work, often when solving equations. And again, just having a conversation around what makes this a good strategy, what are the advantages of this strategy, right? It's quicker, it's something we're familiar with. It's an easy way to just check those two solutions if they hold true. We don't have to rearrange the equation and solve for 0. We could just substitute that 1,000 in right for the revenue. Disadvantages, if we had to substitute, and we can look big picture. We could pull away from this problem. What are the disadvantages in general of substitution? Well, if we don't have a whole number or an exact number, in this case we have decimals, we don't have an exact, let's say we had the square root of 2 as a solution, substituting it in is going to be a lot harder, especially if we don't have a calculator, and it's easier to make a mistake that way. So it's hard to really substitute non-exact solutions. Also, substituting in doesn't actually end up telling you the correct solution when you're checking it, right? It just tells you if those solutions are correct, but it doesn't tell you, what that other correct solution might be. So if you were checking your own work, you'd have to actually now go back and do the problem another time as opposed to just using an entirely new strategy that's going to give you 2 exact answers that you can use to verify your work. And then the third strategy that I chose to feature here is graphing. And this student would have used a graphing calculator. And while students are working, you can encourage them to have a graphing calculator open. You can encourage specific students to try to use a graphing calculator because they might not immediately gravitate towards this. And again, what strategy did they use? What are the advantages? Well, it's super quick. It's going to be accurate and correct. But you might not get a very exact answer because the calculator is always going to round the solution. And you might even point out a couple of other things, like why did they set it equal to y? Why did they move the 1,000 over? What are you actually finding when you're solving this on the calculator? You're actually looking for the x-intercepts, the zeros, things like that to push student understanding. Another strategy that you could feature is completing the square. If anyone did that, I think for this one that would be quite tricky, but you might have a student who use that strategy, or you might just talk about it. What's another strategy we've learned already to solve quadratic equations? When would that one make the most sense to use? When would completing square make the most sense to use? And so after completing this and having this summary conversation, we can now come to this slide. What are the ways we can check to see if a solution is correct? And students can answer this based on that conversation, and you just gave them a whole bunch of ways within that space to talk about it. If you wanted to even modify this, you can ask what are the advantages and disadvantages of some of these ways. And then what are the common errors to avoid when applying the quadratic formula? How can we check if we made any of these errors? And this connects back to also the lesson from the prior day when we were really analyzing errors within the quadratic formula. Okay, so in summary, really giving students an opportunity to grapple with these difficult problems, using 3 reads to set them up with an understanding of them before they tackle them, and then having a really deep conversation about all of the different strategies that could be used and featuring student work. If students are making mistakes, you might feature those misconceptions as well to have a full conversation around them. If a student tried a strategy but was unsuccessful with completing it, you can also share that work and facilitate a conversation around what would be the next step within their strategy. Where was the mistake made? How can we complete this strategy? That's especially true if you don't see anyone say use the quadratic formula. You can pull a piece of work where someone was using the quadratic formula and kind of work together to finalize their work. And again, you have to think about what makes sense for your kids, what their needs are, where their levels of understanding are, and where the misconceptions are happening.